we're going to spend a while talking about migrating to PostgreSQL. Um, and there's a lot of interesting things to consider, both technical and non-technical, that come into play as you undertake migration. And hopefully I have some case studies from the wild to share with you guys about some migrations that I have been part of, and then talk about some of the lessons that we've learned. So quick introduction, my name is Jennifer Scheuerell. I've been working as an independent consultant building custom data systems for 20 years. I started out as an Oracle application developer, pretty quickly found Postgres. I've spent 15 years working pretty intensely on Microsoft SQL Server systems. I've also worked with SQLite and MySQL. On the team, I joke that I'm a database chameleon. I can kind of work with any of them and move between them pretty happily, though I much, prefer to be working in Postgres whenever possible. So, thinking about migrating to Postgres, like the first piece of considering that is the various options that are available for a relational database management system. So here on this slide, I have the first four we have here: Postgres, Microsoft SQL Server, Oracle, and MySQL. Those are the top four relational database management systems that are available, and they've been the top four for a long time. I included SQLite on this because it's something that's getting increasingly used as a database behind web apps in particular. And one of the case studies that I'm going to share with you guys is migration from SQLite over to Postgres. So it doesn't make the top rankings of use for systems, but it's becoming more and more common in our world today. So when choosing which software you'd like to use for your database, there's a number of factors to consider. There's, of course, the cost of the software directly that you need to pay. And I believe for all of the commercial software, these are now typically like per core, per year prices that you're locking yourself, well, not necessarily locking, but you're committing to. Oh, yes, sorry, and I meant to say, so Postgres, if anybody that's not familiar with these, Postgres, MySQL, and SQLite are our open source options here. Oracle and Microsoft SQL Server are commercial paid software. So there's the cost, there's performance. There's really quite a wide variety of performance that you're going to get out of these different platforms depending on what you are trying to solve and what your project is doing. There's also the ability to integrate with external systems. This is something that over 20 years, we used to build systems much more in a silo. They had to do their job, they had to do it well, they had to give their piece out. However people would interact with other systems, you kind of left that to the people. And that's really not true anymore. Now we expect our systems to interact and to be able to give kind of more comprehensive solutions out to the users. And so integration has really become a much bigger piece of choosing your software and potentially choosing to migrate over to Postgres. And then the variety of tools. Like if you guys were just over in the Postgres 14, you were hearing about some of the new tools that came out in there. Postgres has a lot of really great tools, and we're not going to be able to dive into all of them, but I am going to talk about some of the ones that are most relevant for migration. So again, why would a team choose to migrate to Postgres? There's a lot of comfort in doing what you did yesterday, presuming nobody yelled at you and you didn't have to stay late and nothing broke. But there could be these both identifying that the system is not keeping up over time and various things that can give you these hints that a migration may be in your future and it may be the right thing for your team or your project. So security obviously is a really big one. Data security is huge, and having the right tool to be able to keep your data secure is important. Reliability. Like, are you sure when you wake up and step into your office on Monday morning that everything is going to be running how you left it on Friday? Automation, how well you can set the system to just run, where there's, you have your team keeping an eye on things, but there's no interventions required. The performance, right? So many databases today are behind a web application, and users sit down, they log into that web page, they want their data given to them fast, and regardless of the size of the actual data behind it. Then integration tools, as I said, the systems that I've been working on, the requirement to integrate across and pull data or push data between other servers and systems is growing every year, and it's something that we now are doing all the time, and it's just part of our daily world. And then cost. Some groups have a lot of money to put towards their database systems. Not everyone does, and not everyone is looking to spend their money on the software. Like, perhaps you would better spend your money on people or other things that would allow your team to be more effective. So in thinking about how these 5 database management software tools compare, I put together this little slide. This is mine. This is not like any official ranking of them. But just looking at, so of course, if we look first at the x-axis, that's the expense. So we've got our 3 open source options stacked on that bar because they are free. The next more expensive one is Microsoft SQL Server. And then, of course, Oracle is kind of legendary for its expense. It's not an inexpensive piece of software. If you haven't looked up the prices, they're pretty amazing. And then looking then across on the y-axis, like how advanced is the software? How reliable and how performant is it? And Postgres is very much on par with Oracle as far as all of those features. Below that, MySQL. Again, this is my slide. I'm, not. It's less reliable. There are things that can hit, and then SQLite is really at the bottom. I don't think anybody would argue with that. SQLite doesn't allow concurrent use, and it can't scale very well. So it's definitely the lower of those options. And so, the other thing to think about is that if you are right now considering migrating a system or a database to Postgres, you are not alone. Postgres has been increasingly popular, and so I just pulled this screen grab off of DB Engine's ranking. And they rank all of the database engines, not just the relational database engines. And Postgres has won the Database Management System of the Year for 3 of the last 5 years. They're the first software to ever win 3 times. So there really is a strong kind of upswell of people talking about and using Postgres more and more. And again, Postgres, well, I don't think I said this yet, but Postgres has been around for a very long time and is a very well-established software with a very well-established community. So about 5 years ago, I was undertaking a big migration project, and I came upon this white paper. These are a couple screen grabs from the website from Dimitri Fontaine. He's one of the core contributors to the Postgres project. And he had written this white paper kind of sharing his experience and advice for undertaking migration. And you can go, if you go to is my cursor coming up? Can you see it? Okay. So here, this is the website you can go to, PGLoader.io. If you want to download the white paper, he just asks that you give him you give your email address, and then you get sent the link to download the paper in your email. It's such a useful, just really well thought, well written, easy white paper to read. But the idea behind it is this really builds on kind of the DevOps tools that we've all been adopting over the last 10 years or so, where building on the ideas of continuous integration and continuous development. Continuous migration really, it just has been it has made my life so much better. I will say that. Like, we're going to get into some of the case studies where I'll explain how that has worked. But I cannot recommend that you take on a migration project from this continuous migration approach enough. It's really, the framework of it is really just, it's fantastic. So you can see this is from the white paper. The core idea is that you set up your new environment. You need your new hardware up and going. You, you, you you build your tools that migrate your database to the new environment. And we're going to talk about some tools that are available in Postgres that make that a lot easier than it might be otherwise. Once you have your sort of pipeline together that takes your current production data and writes it across into your new Postgres database, you then rerun that every day until you do your final cutover. So in the same way with like continuous integration and continuous development, you're kind of exercising your publishing to production on a daily basis and these sorts of things. This is exercising your migration on a daily basis. And that might sound like overkill sometimes, right? Like that, do we really need to do it every day? And I would really say yes. In my experience, doing it every day has been brilliant, because if you run this once and then you sit back and you're like, okay, we got it, we built the pipeline, it worked. And then you do some more of the different team pieces and you schedule the migration and you do the rest of it, and you come back and you run it and it doesn't work. And I promise this will happen. And it will be, sometimes it can be that someone uploaded, some data came into your production system while you were doing these other things that broke the migration pipeline you built. And you're not seeing it because you haven't been rerunning it each day to know that it still works, right? When you have a living system that you're migrating across, it's really critical to do this from this continuous migration perspective. So let me quickly introduce the case studies that I'm going to give you guys some examples from that I've worked on. So there's three different, well, it's technically four different websites, but two of them are kind of a pair. So the first website we're going to talk about is called Cedars. So all three, four, depending on how you count them, of these projects are projects that I've done as a consultant to the California Public Utility Commission. I work for their energy division in processing their energy efficiency data. So how many people in the room have ever paid a power bill in California? Okay. You fund all of the work that is done by the CPUC Energy Division. They authorize a budget of $1 billion every year that goes towards programs to save energy in the state of California. This has been happening since the 1970s. California is considered the world leader in energy efficiency. And it's not because California thought it would be fun to do, it's because California ran out of energy first. And so they have been the front runner of this, of energy efficiency, since anyone really started doing it in any sort of scale. So Cedars, the first system we're going to talk about, is it's a big system. It's big data. It's where all of that data for that $1 billion a year of investment in energy efficiency gets reported. It's where the groups that are running those programs apply for their budgets and say what they want to do in the future year, and it's where they report everything, every single action, every single light bulb or HVAC system that's been upgraded in this state gets reported back into this system. It's been online since 2015, and we receive about 1 million records a year just of the activities that happen in this state. And so this is a really big system. It started out in Microsoft SQL Server, and we migrated it over to Postgres. The advice letter site is another site that's for the CPUC. but it's very different, and it's very simple comparatively, and a much smaller project. So advice letters are documents that the utilities, like PG&E and SoCal Edison, when they're setting their rates for what they're going to charge customers for energy, they have to send a PDF document, kind of a legal letter, to the commission that outlines what their rate change will be and why they're making it and how it was authorized that they are allowed to do this. These documents are submitted to this advice letter website. So it's a Postgres, well, now it's a Postgres database. This project is the one that started out with SQLite. So you have a database backend, a Django frontend, and it's an electronic document store. And we even use just a commercial or a open source electronic document software for it. And so then the last one we're going to talk about is actually a project that I'm working on a migration for right now. And they call it the Energy Data Web. And this is 2 additional sites that have they're places where they manage documents and projects and provide public-facing resources to kind of be transparent about the work that's being done at the commission. So again, we're going to talk about the data problems, like what was going on, what motivated the migration, sort of the non-technical side of undertaking a migration. Then we'll dig more into the actual tools and the technical side of the migration, and then talk a little bit about the lessons. So really briefly, this is just a screen grab of Cedars. It's a website that presents tons of tables. Like the summary table that's on the screen there is it's summarizing several million records out of about 8 different tables. And so this is a case where we really needed strong performance. Like we need to be able to give these snappy web summary tables off of real, very large data sets. And it's been a really big project. So lots of money, giant servers. It's been continuously developed for 8 years now. This is just a quick screen grab of the advice letter site. Again, it's very simple. It's a PDF document store with a database backend. Then the database, if you're wondering, wait, you're putting the documents in the database? No, of course we're not doing that. The database manages all of the metadata that describes the documents, and that powers all of the searchability and findability of everything. And also, the tool that we use for this site has optical character recognition, OCR, so it reads the PDF and allows users to search across the content of the PDFs as well. Energy Data Web, these are really quite simple sites. They're older, they run different web platforms. They are right now both using Microsoft SQL Server, and we're looking to migrate them to Postgres. So this is one where we haven't done the migration yet. We're still in the initial steps of agreeing that the migration needs to be done and planning for exactly how and when it will happen. So as I said, I've been part of doing a number of migrations, big and small, and regardless of the complexity and the size of the tool that needs to be migrated, there is a set sort of script for what you need to do to undertake a migration. The first piece is to get everyone to agree, the decision makers in particular, that the migration needs to happen. That can be the biggest barrier, honestly. And what I have seen in real life is actually just getting everyone to, these first 2 steps together, agreeing to undertake the migration, and then setting aside the time and budget and the people necessary to undertake it. People often want to kind of cheat that process a little bit, which I'll talk about in a moment. you sometimes can cheat that process a bit, but you're usually going to pay for it. Um, so once you've done those two non-technical pieces, you have the consensus, you're going forward. Your next step is to plan the new server, the architecture, choose how many cores you need, what your memory, your SSDs, do all of those pieces, plan out your new hardware. Then you're going to build out your new servers. At this point, you set up and you run your continuous migration pipeline, right? You get the data moving from your current system into your new system. And again, once that's done, the first time, you just set it up so it runs again every night. I mean, it doesn't have to be at night. That's typically the optimal time to do it, since most of your users will be sleeping. Once you have the continuous migration running, you want to make sure that you set up your backups and automate your process for recovering your system, your new system. It's really strategic to do that before the cutover, because you can take the system down and rebuild it from your backup and exercise that several times to make sure you have it perfect before it becomes your production system. Once it is the production system, being able to exercise your restore from backup becomes a much trickier process. At that point, you go back to the non-technical. Then you just have to work with the decision makers and the team to schedule when your cutover is going to be. When you get to your cutover, you run that migration one last time. Because you've run it every day for the last while, it just works. There's no surprises in the 11th hour. The advice letter site that I talked about, we just did our final cutover like 6 weeks ago, something like that. Flawless. It just it went exactly according to script. And that is 100% because we followed the practice of continuous migration. At that point, you're just cleaning up. You want to retire your old servers in whatever way is appropriate for the team and the group that you're working with, and then you're done, and you're in this new space that's improved. So this is kind of a storytelling slide for us. So when you decide to migrate, what I've seen is that there's kind of two camps of deciding to migrate. People who have experienced an incident that typically becomes known as the incident to that team of people that shakes them, that proves that they need to do something differently. I had an experience as a consultant where I was on a team. We had a Microsoft SQL Server database. We had probably 20 contractors working on that database server doing production work. The group had just missed their deadline for having the work that they were working on done. So everyone is working around the clock trying to get things completed as quickly as possible, and the server crashed. We all showed up the next day, and there's no machine to connect to. It took 5 days to bring the server back. And I was one of those 20 people waiting for the server to come back so I could finish my work. That was a piece of the larger deliverable, and it was agonizing. It was really rough, and that shook people, and that made everyone start thinking about what are we going to do to get into a different situation where we're not going to have something like this happen again. The Energy Data Web project that I just mentioned, we see our incident in front of us, but it hasn't happened yet. We have an authorization system for those websites that was built by a consulting group that built those sites 10 years ago. They put their proprietary authorization system in front of both of the sites, so they both authenticate through this same system. They closed down during COVID. They were a consultant to my client. My client asked me if I would please inherit their sites because they were closing. I said, okay. In the transfer, they said, this is our proprietary system. It's gonna break at some point. We are no longer maintaining it. We are closing our doors. That's going to fail on you. So we know this is ahead of us. We don't know how long we have, but we have to move the system off before the authentication system fails. We've also had some actual hardware problems with those sites where twice now one of the servers has entirely filled its hard drive. It's generally a good idea to not set your servers up where they can fill their own hard drive, like the OS hard drive. The server falls over. In one case, it knocked out 3 websites. In one case, it only knocked out 1 website. That's the sort of thing where if you saw it, if you knew that it was coming, it would be very easy to avoid and to mitigate. It'd be 5 minutes of work to make the drive a little bit bigger. Once the drive is completely full and you can't SSH to it because there's not enough room on it to write your key, it's days of work to rebuild those machines and get the data off and get the new one going. So that's happened to us. I've been managing those sites for about 18 months now, and that's happened to us twice. So this is really just the kind of, the scary stuff, right? You want to undertake a migration and finish it before something bad happens. So that's really just the point to make here. The last kind of moment to talk about these non-technical steps that get you to actually executing a migration is the piece where you dedicate resources. And I alluded to this a little bit before, where this can be really tricky to get people to accept that, often like a motivating factor for undertaking a migration, it may not be that you want better performance or better reliability. It may be that you want to lower your cost. And you know that, or like you've done the work, you've run the numbers, you can say if we undertake this migration, our maintenance cost on the new system will be half what we're paying each year to maintain our current system. We're going to see a really nice cost drop for every year going forward if we just do this thing. And that can be a really compelling story to decision makers, right? What they don't like is this little brick on top, where you need to actually dedicate resources to building out your new system and running your migration on top of your expensive current maintenance. And so what people often ask when you get to that moment where you're like, okay, how are we going to plan? How are we, we're freeing up time for our team to be doing other things and not doing just maintenance, and that we're lowering our costs. But to get there, we actually need a couple extra people, and we need a little more money to be able to build out the system that we need. And what people, you guys can probably guess looking at this, what people often want to do is say, well, if we're going to be done with the old system, let's just drop that build new system into our maintenance budget for our current system, and we'll just stop maintaining it. And it probably won't die before we get the new system up, right? I've seen that go sideways once. The system went down in 2018. They stopped maintaining it. It was hacked. They couldn't get it back up. It is still sitting in a server room with tape around it. And that web resource that a lot of people used for day-to-day work vanished overnight. So just to really encourage people, it hurts a little bit. It's hard. You can't just create people on your team, typically. Worst case scenario, you have to hire a consultant, somebody like me, to come in and help for a few months to give the bandwidth, because you don't want to necessarily hire a FTE if you think you only need it for 3 months. But just to say that this is really one of the things that I see groups struggle with, where even once they've decided they want to migrate and they've decided where that they want to migrate to Postgres and they kind of know what they want to do, figuring out how to allocate resources to the migration can be a really tricky piece. Um, so setting aside now these non-technical pieces, let's get into the fun stuff. This is actually how we can use Postgres and why Postgres is such a great tool to migrate onto. So again, these are just our generic migration steps. Oh, sorry, I reorganized these this morning. I thought we were in a different spot. This is just about the server expense. So Oracle is kind of famously expensive. I Googled like how much does Oracle cost, and this little blurb came up, and they suggest perhaps the most expensive piece of software on the planet. They give a case here where you've got a 4-processor quad-core server that would cost $2.4 million. This is, of course, the premium Oracle. You could do an Oracle database for less than that. A lot of the systems I'm running are 32 cores. If you're in all of these licensing now for Oracle and for Microsoft SQL Server is done per core. So if you've got a big machine because you've got big data, you're going to pay big dollars. Okay, so Oracle's, it's funny. You can kind of laugh at it and think about who are these people, who has the budget to decide I'm going to run Oracle. There are lots of people, and it's a great software, very comparable to Postgres. But Microsoft SQL Server is a very common solution as well. I'm from Seattle, so it's very common in my part of the world because Microsoft is in our backyard. But like right now, I went onto the AWS calculator and pulled up the instance that I just spun up a couple new databases for a client, 32 core systems. I could run Postgres on Linux on that exact instance. I can run almost 4 of them, not quite 4. It's like 3.7 for the cost of running one Windows Microsoft SQL Server machine on the exact same hardware. So that I've actually have a client where that cost saving has allowed us to improve our security because we were able to then run multiple machines and put things in the right places and distribute things and keep confidential data away from where more people have access because of the cost savings, which was not something I had originally anticipated. So just to say that the saving money can actually translate into other features or benefits as you undertake a migration. So reliability. So the advice letter site that I told you guys about, this is a site that went live in 2014. The total budget for creating the site and running or paying the cloud server for the first year was $3,500. And it works fine. It had very few users. People are uploading their PDFs. They didn't really maintain the site. They just had put it up and started it running and just kept it running. 8 years later, they called me back and said, we need to upgrade it. They had done a pen test on the system, and cross-scripting vulnerability had come up, and they wanted to address that. And so in addressing that security concern, we were able to actually undertake the migration and do this whole piece in one big chunk of work to kind of level them up to a new platform that they were going to be able to take forward. We suggested 5 years. That fits better to the open source model of how things are, lifespan of software releases. And then they fully intend to just, we call it coasting. They're going to coast the platform for the next 5 years is their intent. And again, I shared the story with you guys earlier about the Windows servers that crashed and took 5 days to be restored at a very critical development time. So those systems have both moved on to Postgres. The Microsoft SQL Server one has been on Postgres now since 2015. Yeah, 2015. And we have had 0 days of downtime. Touch wood. I don't want to jinx myself, but that the same tool that was run in Microsoft SQL Server and went down for 5 days has been running in a much kind of bigger scale with more users since 2015, and it has had 0 downtime. And then the integration tools. So this is my favorite, my favorite Postgres integration tool, and it's foreign data wrappers. When you are migrating to Postgres, you set up your Postgres server, and then from that new Postgres database, you can go to your existing, or the current or old, soon to be old database server, and grab data and pull it into your new server using foreign data wrappers. I put a little snippet here. This is the last foreign data wrapper I made. So I just grabbed a random one. This is a public read-only data access. So you could build this foreign data wrapper in your own database, and it would connect to this. It's a project run by the California Technical Forum, and pull their data into your local database. And so in migration, so I use foreign data wrappers both to do integration from my Postgres servers with other external servers, where we were talking about how now that's generally expected. Like, people don't want to have to go over to this website and grab these things, and then come to this website, grab these things. They just want you to grab that for them and let them just directly interact in one place. Foreign data wrappers enable that in just a really lovely way. This particular example, when I ran it, it took about 8 seconds. And in those 8 seconds, it went to the foreign server, queried all of the particular data element that I wanted, pulled it over to my local database, and materialized it into a view. So I have the data element that I wanted in my local server that I can work against and have really great performance. Another the thing that I think is just amazing about foreign data wrappers, it's not just that you can go from a Postgres database to a Postgres database. You can do a foreign data wrapper to Microsoft SQL Server, to Oracle, to MySQL. It works there's extensions that allow you to wrap all different kinds of foreign servers, which is just hugely great. This we were doing a table at a time. Yeah, tables that had about 1 million records, and the reference system that we're pulling out of they don't really embrace the relational structure. They've put all of their stuff into JSON, and then they make it available as one giant flat table that has like 150 columns. So I was pulling data out of a table that has about 1 million records and about 150 columns. And do I have any Django developers in here? Anyway, okay. I work with a lot of Django developers. We do a lot of Django front ends for our databases. I ran this as proof of concept and to get the data into my system once for some testing I was doing. Then I asked my Django guys I said, okay, this is, we want to go grab this field out of that database. And they were like, oh, can we do it the way we usually do? I said, yes, fine. They went and did that. It took them 10 hours to pull that data through the ORM. 8 seconds, 10 hours. So these foreign data wrappers are snappy and powerful. Like, you can grab huge pieces of data really fast. Performance. Like, with Postgres, you get such strong performance. And if you're doing upgrades, your performance is going to improve every year, because every year the new release of Postgres has better performance. So there's a ton of performance that you gain simply by doing the migration. What one of the things that I've used a lot in this bigger system, Cedars, that I've told you guys about, where we have tables with, we're at about a terabyte of data. We have multiple tables that have lots of columns and many millions of records, and we have to join them all together and synthesize these summary statistics, like the table that I flashed up earlier. And so the way that we're doing that and getting these aggregated data and serving it to our users in the sort of real-time web right now, I click the button, show me the number sort of way, is through materialized views. So we set up materialized views that take the underlying data and aggregate it up to exactly that summary that we need. And then we just refresh them. We set triggers so that they refresh when they need to. And it's been amazingly, like the performance on that has just been fantastic. So it's not just that the database itself performs really well. It's that you can leverage things like materialized views to bring performance even when you're trying to do something really fast on a really large data set. So let's see. Oh, and this is like also such a cool tool. This is another one. This may look familiar because this is the same person for the continuous migration white paper, Dimitri Fontaine. He created an extension for Postgres that's called PGLoader. I've got the references there, and I am going to share these slides, so you'll be able to get them from scale as well. If you want to look at these, I'd really recommend looking at this. It's an extension where you write one line of code that effectively says, well, so first you'd have to build out your new Postgres database, like your new hardware, your new software that you're going to migrate onto. You've got your existing system. You take PGLoader, and in one line you can point it to the existing system and point it to the new system and say go, and it reads the existing database, builds out the schema for it in your new database, and then moves all of the data across for you. It's not necessarily going to work perfectly on every use case. Like I know some database systems that have a ton of really weird stored procedures and things like that. Probably not going to be able to do something like that. There's a case study on his website where they talk of someone hit him up and said, hey, thanks so much for this. I migrated a 1 terabyte MySQL database to Postgres and just set up PGLoader and hit go and left for the weekend and came back and it was done. So it really just a super cool tool. Yeah. Yes. Oh, to do the daily continuous migration versus the yeah. You don't need to do it again. Yeah. I don't know. Yeah. No, I stuck a couple of my business cards at the back, and if anybody wants to grab one, I'd be happy to try and find that answer. I don't know. Um, I'm not sure about Oracle stored procedures. I remember. I was trying to keep all of this. Yeah. Let me check. Can I follow up with you after this? Yeah. I did use this for the SQLite migration um, because I am more used to Postgres and not SQLite. SQLite is really weird to me, so I was super happy I could point this at it and it just worked. So again, just going back, the reasons we choose these tools, we want our security, performance. Postgres is really hard to beat when it comes to choosing like what's the best, what's the most, uh, strongest tools, best performance, lowest cost. Like I think anybody would have a really hard case choosing another. Um, not others get chosen all the time. Like I don't mean I'm not naive about that, but that's really when I see those decisions, they're not made for reasons like cost and performance and how well it will grow with you as you move forward. They're made for other reasons. People choose Oracle because the company they're in chose Oracle previously, and you're continuing on a common platform. And which is, that's a real thing. Like you don't necessarily want to. It can be really confusing and difficult for groups to say, okay, well, you guys all know Oracle and you're all Oracle developers. I'm going to build you this Postgres platform, and you're going to inherit it when I'm done, and you'll be fine. Like that's going to be a hard sell. Um, yeah, yeah. So I have always used the open source product. I haven't. I mean, EDV is great. There's, you know, um, it's, but effectively, I've always just used open source Postgres, um, and honestly, like, I've been a member in the Slack community. Postgres has a Slack community for those of you who Slack. I think when I first found it, there were about 2,000 people in there, and now there's something like 12,000 people in the Slack community. And there's a number of core developers who answer questions in there. But that's a great place to go to talk. There's a bunch of directed channels as well if you're looking to talk. Like I think there's actually one on 4 data wrappers and some various things like that. And so I typically maintain the systems that I've built, and that's one of the reasons I picked Postgres is because I spend very little time maintaining them. If you set the system up right at the beginning, and you don't like, oh, let's put something else on the database server with the database, or like these kind of silly things people will do, it just keeps working. Like if you take care of it and you set it up right, it just keeps working, and the administration is so close to zero. It's amazing. Like I spend very little time doing administration, and that's by design. And that's not the part of it I like. I like being in and manipulating data and building out tools and things like that. The administration part is not what I show up for. So I love being able to have that really light touch on database. And then the Postgres documentation, it is so well done and so comprehensive. If I don't remember something, I just Google it, Postgres, and whatever the words are that I need, and I've trained my Google to go straight to the documentation pretty much, and get the answer, and it's really fantastic. Like, I rarely get stuck. Uh, so again, just briefly, the non-technical hurdles, getting everybody to kind of accept sometimes and agree that we're going to that it's important to do this and it's important to do it now. Maintaining the current system while you build out the new one, and not just letting it fall by the wayside, and then just executing the switch over. On the advice letter project that I told you guys, that was actually the first project that my team did as continuous migration, and continuous migration saved us on that project because we got to where we were done. We'd run the continuous migration off the times. We'd done everything. We said, we're ready to cut over. And so we said, okay, we're going to check with IT. Anybody want to guess how long it was? 3 years later, they told us we could go. We had not taken that project from a continuous migration framework, we would have been in a lot of trouble. We would have been completely back at square one. So, in conclusion, Postgres for the win. Every time I have moved people onto Postgres, they've been incredibly happy. They've had reliable systems. They've had zero downtime, and it's opened up doors to be able to do kind of smarter integrations and more things that they had wanted to but had been out of reach to them before. And with that, I will say thank you.